everybody, and welcome back to another episode of PDA, your handheld guide to understanding psychological data analysis. Today we'll be going over the measures of dispersion. There are three of them, and the first one is range, which is defined as the width of a distribution. In short, to find the range, all you have to do is take the highest number and subtract the lowest number from it. So it's H minus L. Let's stick with our sample of 2, 3, 3, 4, 7, and 8. It's already ranked ordered. That's nice. Remember, we still have the mean, mean, which is symbolized by the Greek letter mu. The mean is still 4.5. That hasn't changed. So to find the range, we take the highest number, which is 8, and subtract 2 from it, which gives us 6 for the range. Ranges are very easy to calculate, as can be seen. Next is the variance, which is just a bit harder and has a rather, well, for a beginner statistician, this looks pretty fierce. The variance is defined as the spread of a distribution. To find variance, which is symbolized by a lowercase Greek letter sigma, which is a little loop and a top over it, and this is squared. The formula for the variance is sigma, which means add everything up. Sigma of x minus mu, so your x's minus your mean, squared, divided by n, the number of x's, minus 1. So what that means is we need to take all of these numbers, subtract 4.5 from them, square that, and then add all that up. And then, after that, divide it by, if there's 6 n's minus 1, 5. To do a variance, you want to set up a table like this. We'll have 3 columns to start with. First one will be x, and we'll list all of your numbers. So we've got 2, 3, 3, 4, 7, and 8. The next column is x minus mu. And all you do for this is you take each x, like 2, you subtract the mu, or the mean, from it, which is 4.5. So 2 minus 4.5 is negative 2.5. You do this for every x, and eventually you'll fill the table out. The third column is x minus mu squared. And all you do for this is you take the answer you got in the second column, and you square it. Any negatives you have will go away because a negative times a negative is positive. And you'll get this in your column. Then what you need to do is add it all up, just like the sigma says over here. Go ahead, add up the numbers, work the table yourself, pause the video, and we'll come back and I'll explain the rest. Okay. So, once you total this up, you should get 29.5. But we're not done yet. Not quite. Don't forget, we've still got the denominator to work over here. So, 29.5 divided by n minus 1 is 5 will give you a variance of 5.9. Congrats, you have your variance now. That's the hardest part of this lesson. Next is the standard deviation. This is defined as the spread of the distribution. How far apart are each other? Now the formula for the standard deviation is just the square root of the variance. So with a variance of 5.9, you square root that and you get 2.43, or somewhere in that range, for your standard deviation. That's it. Now to really explain what a standard deviation is, we're going to have to go into a little more detail with it. Give me a second to clear the board. This is what is known as a standard distribution, or a bell curve. I've applied all that we found from our little sample to this, and let me try to explain graphically what standard deviation is. Through our calculations, we came up with a standard deviation of 2.43. We also came up with a mu of 4.5. So right smack dab in the middle is 4.5. That's the mean. That's the average of everything, the arithmetic average. One standard deviation away which is 4.5 plus 2.43, which is our standard deviation, is 6.93. Again, one standard deviation away, this time subtracting because we're going to the left, then we're going to the left, negative, is 2.07. For now, that wraps up the measures of dispersion. If you have any more questions, please see the link at the end. Like other occult techniques of divination, the statistical method has a private jargon deliberately contrived to obscure its methods from non-practitioners. Now, you're in on the secret.